From the moment humans first gazed into the night sky, the stars have inspired curiosity and wonder. They look peaceful, everlasting, but they do not live forever. Stars die in titanic explosions. But scientists believe that a star's death is also a beginning.
Stars are particularly important because stars are the source of all elements. Only hydrogen and helium were created in the original Big Bang, which made the universe. We now think that the very first objects formed after the Big Bang itself were stars, giant stars.
One such giant star can be found in the skies of the southern hemisphere, in the constellation Carina, named for the keel of the ship from Greek mythology that carried Jason and the Argonauts. Here, in the midst of the giant Keyhole Nebula, shines a mysterious star called Eta Carina.
Eta Carina is the mad emperor of visible stars.
It's a freakishly large star that's very, very active.
Basically, Eta Car is a star in its depth ropes. It's very near the end of its life.
Astronomers have found evidence that without the death of massive stars like Eta Carina, nothing in our world would exist. They are, in a sense, our most ancient ancestors.
If you don't understand massive stars, you won't understand where we come from. Because we come from the stars. All of us are once inside a star.
The carbon that makes up much of our bodies had to come from a star, from the inside of a star, because it's created there where the nuclear reactions are going on, the nucleosynthesis. So how'd that stuff get out? How'd it get in us? Well, it got out because it's created in the interior of a very massive star like Eta Car that eventually does explode.
We all know about explosions. We see them all the time. Explosions in space work much the same way as they do on Earth. If an object gets hot, it will expand. But if something prevents that expansion, pressure builds up, and something's got to give. Like the kernel of popcorn, Eta Carina is torn by opposing forces. It is a fight she will ultimately lose. In 1996, the Hubble Space Telescope gave us new, sharp images of Eta Carina. The star itself, a giant luminous blue variable, is hidden, obscured by clouds of gas and dust, evidence of a massive eruption over 150 years ago.
We used to think of explosions in space being spherical things, rather dull and boring. We now realize that most things in the universe that explode have angular momentum, which gives an axis of symmetry. And they tend to blast stuff out the poles and make two big lobes.
Every star balances two opposing forces, the outward pressure of gas and radiation from its nuclear furnaces and the inward pressure of the star's crushing gravity. These two forces hold a star together. Our middle-aged sun balances these forces very well. It's a well-adjusted, stable sort of being, most suitable for us here on Earth. But Eta Carina is like a wild child, locked in a desperate fight to keep from tearing herself apart. Her instability comes from her size. Eta Carina is perhaps the most massive star in the entire Milky Way galaxy. At over 120 times the mass of our own sun, Eta is simply as large as a star can be. At this tremendous size, she could explode at any moment.
Eta Carina might become a supernova in 100,000 years, or next Tuesday. We know that this particular object is pretty near the end of its life. Now, what pretty near means in this case, I can't promise you exactly.
Eta Carina has been photographed and studied in every part of the spectrum: radio, infrared, visible light, ultraviolet, and X-ray, and yet remains a puzzle. Right now, astronomers are using the orbiting Chandra X-ray telescope to investigate a mysterious change in the star, one that occurs once every 5.5 years.
The star itself changes. It doesn't explode exactly, but its spectrum just changes its character. It looks as though the gas around it rearranges itself.
The cause of Eta's periodic blip is unknown. It may be found deep in the core of the star, or perhaps beneath the shroud of its nebulous cloud lies not one mammoth star, but two, a binary star system.
maybe this massive star has another massive companion going around every 5.5 years. Those stars interact, generate X-ray.
Eta Carina is bright, hot, and violently unstable. Scientists think she has flared up and disappeared throughout human history.
Around about 1840, Eta began to get brighter and brighter and brighter.
By about 1842, it was one of the brightest stars in the sky, still highly irregular, and very briefly became the second brightest star in the sky.
Eta Carina's behavior is best described as a volcano in the sky.
The whole behavior was like a volcano. There were pre-shocks. There were fluctuations in brightness. Then there was a titanic outburst, and after the outburst, it seemed like it was stable.
Basically, once an outburst begins, it keeps going and eventually subsides, just like a geyser or a volcano. And of course, it survives the eruption and lives to do it another day.
Astronomers speculate that Eta Carina has gone through many eruption cycles. The last one begins in 1820, with Eta shining dimly in the heavens. Suddenly, she erupts. Twin lobes of gas expand outward. Eta sheds more than 3 times the mass of our Sun. Over the next 20 years, she grows into an intensely brilliant first-magnitude star. Between 1840 and 1870, the gas nebula grows over 600 times its original size. But as it expands, the gas particles cool, forming dust, which blocks the star's fiery center. From Earth, Eta disappears to the naked eye. After this great eruption, the star shrinks back to its normal hot blue state, but remains highly unstable. Over a century passes, and the expanding nebula grows 40,000 times its original size. As the particles from the eruption spread out, the light from the star shines through once more. In 1980, Eta Carina reappears, barely visible in the night sky. Astronomers think the entire eruption cycle may happen once every few hundred to few thousand years.
In the case of Eta, it's erupted and has survived, but someday it will explode, a massive explosion as a supernova.
When Eta Carina becomes a supernova, there won't be any warning on the outside behavior, because the explosion starts at the center.
A star dies when it runs out of fuel. In mammoth stars like Eta Carina, once they no longer have hydrogen to fuse into helium, they fuse other elements, carbon, oxygen, silicon, eventually producing an iron core. Since iron cannot fuse into any other element, nothing is left to stop the onslaught of the star's gravity, and the core collapses.
Now gravity takes over, and wham, the star collapses down onto its collapsed core. And we think what happens is that there's sort of like a bounce, a rebound.
The plunging star rams into the core and rebounds, a kickback effect similar to dropping 2 balls at the same time. The star explodes. In the dead giant's collapsed iron core, gravity continues its relentless pressure, bending the fabric of space and time to create a black hole, a place where gravity is so strong that not even light can escape. Supernova explosions are usually produced by stars 20 or 30 times the mass of the Sun. But if the star is 120 times the mass of the Sun, the blast could be much more deadly, a phenomenon recently documented as a gamma-ray burst, sometimes known as a hypernova.
When an extremely massive supernova like this explodes, theorists have realized just recently that it shoots out a couple of blowtorches along the axes. That's the gamma ray or X-ray burst. The reason it looks so bright all the way across the universe is that a lot of energy is concentrated along that narrow pencil beam.
But can astronomers tell which direction Eta will shoot these gamma rays? Is Earth in the line of fire?
Most stars, we don't know which direction their axes of rotation point. But with Eta, we obviously do, because with it has that great, gorgeous, bipolar ejecta nebula thing. You can tell which way the axes are.
And so it's very likely the gamma rays would be shot out along that axis. And if you look at the picture, you can see that it's not pointed towards us.
Since Eta Carina is only 7,500 light-years from Earth, the blast of radiation could disrupt satellite communications or knock out electrical grids. But would there be any danger to life?
We're probably safe. But the only thing that would save us is the atmosphere, because the atmosphere of Earth has as much mass in it as 30 feet of water. And that's pretty good radiation shielding. It's fairly good protection.
Exploring the light of distant stellar explosions reveals connections that are fundamental and profound. As we have seen, we are built from the ashes of giant stars. Studying supernovae helps determine the rate the universe is expanding, which in turn helps us answer questions like, when did the universe begin, and how will it end? The future of Eta Carina is certain. Ultimately, she will die in a catastrophic explosion. And some people are looking forward to it.
Yes, I really want to see that. I mean, I would like to see Eta Car explode.
And who knows, maybe one night soon, while someone gazes upon those distant points of light, one will explode in a dazzling display. And it might be Eta Carina.